right, guys, we're on the back side of Unit 4, Day 1 notes, and number 3 says that a function f of x has a domain of -3 to 10, okay, including them. So you can see the equal sign. This is actually in set notation, not interval, okay? And then it also has a range of y is less than or equal to 22. So all values from 22 to -infinity, okay? What are the domain and range of the function defined by this? So this gives us exactly what we're doing to x and what we're doing to y. Okay. So what we have to do is we have to break this down. Okay? So when you see that +7 in there, you're now going to think this 7 units to the, don't be fooled, it's to the left. Okay? In that +10, that's going to be 10 units up. So our whole graph, if you pick up our whole graph and move it 7 units to the left and 10 units up, well, it's going to affect the domain and the range. Okay. And the left and the right movement is going to affect your x, okay, or your domain. So if a graph gets picked up and moves 7 units to the left, our domain is not going to go from -310 anymore. Okay. If I take -3 and I move it 7 units to the left, I'm going to go ahead and subtract 7. Okay. So -3, 7 units to the left is going to now become -10. Okay. And if I take 10 and I move that 7 units to the left, now you're going to be at 3. And there's our new domain. Pretty easy. Okay. I'm going to go ahead and do the same thing to my range. Now my range is 10 units up. So if I pick my graph and I move it 10 units up, no longer is it going to go from y less than or equal to 22. 10 units up, we're going to go ahead and add 10 to that. And so we're going to say our range actually is y is less than or equal to 32. Okay, and there's our new range. All right, hopefully that makes sense. We're going to do a bunch more. Okay. Number 4, it says given the quadratic function f of x equals x minus 4 all squared minus 5, an image of g of x, which equals x squared. So this right here, g of x, that's our parent function. Notice he's just an x squared. Okay, he's a basic parabola. You can graph it in your calculator if you'd like. Okay. And then f of x, you can see the x, you can see the squared. Okay, so that's the part of the parent function. But they had to move the square down a little bit because they had to group a number with the x. Okay? You see that -4 in there? That -4 actually means 4 units to the right. You would think left because of the minus, but remember, it's grouped with x. It's the opposite of what you think. Okay? And then that -5 is the same as what you think. So you think down 5, you're right. Okay? All right, so part A says identify the transformations in correct order that were applied to g of x to get f of x. And so we actually already know the two transformations. We know 4 right and 5 down. Which one has to go first? The one that's grouped with x. And so we're going to go ahead and say a shift of 4 units right. Okay. And then once we do what's in parentheses, we go from the left side to the right side, okay, with our transformations. And we're going to go ahead and say shift 5 units down. All right, and there's our two transformations. Okay. Part B says to determine the interval in which the function f of x equals x minus 4 all squared minus 5 is increasing only. Okay, so we're going to go ahead and do a little sketch. We could put it in our calculator if you want, or we can think about it. Okay, so remember I told you that this is the parent function, y equals x squared. If you didn't know what that parabola looked like, you could graph it. Okay, but if this whole parabola is getting shifted 4 units to the right, 1, 2, 3, 4, okay, and going 5 units down, 1, 2, 3, 4, 5, okay, your new turning point will be here, and your parabola will look something like this. Okay? And so they're asking about which interval is it going to be increasing on. Okay? So increasing, we're going to read this from left to right. And as we read our new parabola over here, this would be decreasing. We want the increasing part. Okay? And so we're going to go ahead and say that this is going to be increasing, starting with an x value of 4. And as that arrow goes up, it is still going to the right, and we'll say infinity. Okay? Always round. And there it is. Okay. All right, part C. It says if the function f of x was translated 8 units up and 6 units left to create h of x, what would the equation of h of x be? Okay, so remember that f of x is just plain old x squared. Okay, we're going to create h of x. Okay, so that we're going 8 units up and 6 units to the left. So we're going to do the 6 units to the left part first because that's going to go ahead and get grouped with x. To the left makes me think subtraction, but remember it's going to be the opposite of what you think because it's going to be grouped with x, and so that's actually going to be a plus 6. That's going to be grouped in there. Okay, so we're going to have to move that squared over so that the plus 6 can fit in the parentheses and the squared goes on the outside of it. Okay, 8 units up. That's going to go on the outside of the parentheses, not grouped with x. Okay? And up, you would think positive, and it is the same as what you think. So we're going to see a plus 8 tacked on here. All right, so I'm just going to rewrite that. So it says h of x equals, in parentheses will be the x plus 6, so that we can go 6 units to the left, close it, and square it, because that squared is part of the parent function. Okay? And then the plus 8. There it is. There's my new equation. Okay, common mistake is that you guys will leave the square on the x, okay, and then group the plus 6 with the x squared, but it has to be grouped with only the x, okay? So the square kind of gets separated from it. All right, good guys. Number 5. It says that the graph of f of x is shown below. The function g of x is identified by g of x equals. Okay. Identify the transformations to get g of x in correct order. So we're going to go ahead and look inside the parentheses and do that first. Okay. When you see a number group with x, we're going to say that that's a shift, okay, of 2 units. I would think left, but it's the opposite of what you think. So it's 2 units right. Okay. Down here, we see a plus 3, and so we again know that that's a shift of 3 units. I would think up, and it's the same as what I think. So it's 3 units up. Okay. All right, part B. It says graph g of x on the same axis. So we're going to go ahead and pick out the popular points, which is 1 right here, 1 right here, and 1 right here. Okay, and we're going to take each one of those points and go 2 units to the right with it and 3 units up. And so that bottom point will now end up there. Okay, 2 units to the right, 3 units up. Okay, 2 units to the right and 3 units up. Okay, nice straight lines. I'd make them straighter if I could, but I don't like that one. You do a little bit better than that. He started to curve in. Okay. There we go. All right. And we're going to go ahead and label that as g of x. And so part B is finished. We graphed g of x on the same axes. And now in part C, it's going to ask us to do find g of -1 and g of 2, but they're asking me to do it algebraically, so I have to show my work. So we're going to go ahead and say g of -1 equals, and we're going to go up here and grab that g equation. And anywhere we see an x, it's coming out, and -1 is going in. So the f is going to stay. X minus 2 is going to become -1 minus 2. Close it up, and then plus 3. Okay, and then we're going to do some math. -1 minus 2 is -3 plus 3. Okay, now we have to go and find f of -3 on the graph. Okay, so we're going to go ahead and go -3, and we're actually already on f, right? Okay, the original one was f, just so you know. And that point has coordinates of -3, comma 0. And so f of -3 is actually 0. And 0 plus 3 is actually 3. Okay, so we're going to go ahead and say g of -1 equals 3. And now we could test it too if you want. So if you go -1, okay, because remember what this means. This means that -1, 3 should be on my g of x graph. So -1, +3, and it is right here. Okay. All right, so they also want us to find g of 2. So we're going to go ahead and say g of 2 equals, grab that equation. Anywhere there's an x is coming out, 2 is going in. So we'll keep the f here. X minus 2 becomes 2 minus 2, and we add 3 to it. Okay. And so f of 2 minus 2, which is really 0, and then plus 3. We're going to go to our graph, and we're going to try to see if we can find f of 0. So 0, and we're actually already on the graph. The coordinates of this point here are 0, 0. Okay? And so f of 0 is actually 0. And then plus 3 makes that 3. And so we could say g of 2 is equal to 3. And if you want, we can test it, because what we're going to look for on the g of x graph is the point 2, 3. And if it's there, chances are we're good. So positive 2, 1, 2, 3, it is. It's right there. Okay, and so I know we're good. Okay. Okay, guys. All right, so let's go ahead and see what number 6 has in store for us, and then 7. Okay. Number 6 goes ahead and says that if the domain of W is -7 to 9, and so that's interval notation, like we like, and that the range is -3 to 5. Okay. They want you to determine the domain and the range of the function r defined by r of x is equal to w, x minus 14 plus 2. So we're going to just go ahead and pull this out and state what that means. So that is a shift of 14 units. We would think to the left because it's minus, but it's the opposite of what you think when it's grouped with x. And so this is actually 14 to the right. Okay. That positive 2, that is 2 units up. Okay. So remember that the 14 is a right or left movement, which is going to affect your x, which is going to affect your domain. Okay. Where the 2 up is your y movement, which is going to affect the range. All right, so here we go. If you're going to go 14 units to the right, that's the same thing as adding 14. We're going to add 14 to both numbers in the domain, and that's going to spit me out a new domain. So -7 plus 14 is positive 7. 9 plus 14 is 23. And there is our new domain. Okay. Our range. Well, this graph got all shifted up 2. So no longer is it going to be at -3. It's going to go up 2 from there. 5 is no longer going to be the maximum. It's going to be 2 up from there. So your new range will be -3 plus 2, which is -1, and 5 plus 2, which is 7. Okay. All right, we got one last one, number 7. It says that the function h of x has a vertex point of -9, 5. What would be the vertex of a function j defined by? Okay. So again, in here, we're going to pull out the stuff that we need. That -6 means 6 units to the, you would think left, but it's actually to the right because it's grouped with x, opposite of what you think. Okay. The -7 is going to be 7 units down. All right. So this one's a little bit different, but because they give you a vertex point, you have to remember that in a vertex, in a point, that this is the x coordinate and this is the y coordinate. And remember that this is going to affect the x, and your up down, which we have down, is going to affect the y. Okay. So if I go ahead and take that x coordinate and I make it go 6 units to the right, I'm going to go ahead and add 6 to make it go to the right. 7 units down, I'm going to go ahead and subtract 7. And so my new turning point, or my new vertex, okay, vertex of j of x is, okay, -9 plus 6 is going to get me at -3. And 5 minus 7 will put me at -2. All right, so the vertex of j of x is at -3, -2. Okay. All right. Hope that helps, guys. And I will see you on the next day of notes. Okay. Do a good job on your homework.